In this video, we shall see about the inbuilt functions in Numpy array. So inbuilt functions are the functions that are already existing in Numpy array that has a definite purpose. So some of the functions we shall see in this video: import Numpy as np, and let me create an array. A is equal to np dot array function. Let me give a nested list inside the array. Okay, let me print the array. Okay, so suppose I'm going to apply the trigonometric functions like sine, cosine, tan. So how to do that? They are all belonging to the Numpy module. So I have to proceed it with np dot sine and open parenthesis. I have to give here just a single value. If I just give a single value, what really happens means it just returns the sign of 20 will be returned. So suppose the same thing I just want to apply it on the array A. It is very much possible. I have to just write np dot sign of A. What will be returned means an array will be returned with the sign being applied to each and every element of the array. So let us see. So this is array of the sign value being applied to each and every element of the array. So this is sign of 1, this is sign of 2, this is sign of 3, sign of 4, sign of 5, sign of 6. So the result is also an array. The same thing can be applied to cos, tan also. So now let us go to the arithmetic functions. So the same way we can write np dot add, and inside the parenthesis I have to give two arguments. The first one is the name of the array, the second one is the number that is to be added. So in this case, as the name indicates, add function will add the given value to all the elements of the array A. So let us see. So now 2 is being added to each and every element of the array A. The same thing can be done with all the other functions like subtract, multiply, mod. So all these functions work the same way. So what are the functions that are there in arithmetic that supports arithmetic operation means you have add, subtract, multiply, divide, mod, and remainder. So in this case, mod and remainder, both the functions work the same way. And mod actually returns the remainder. So mod a comma 5 means, so whichever value that will be the remainder, that is the remainder whatever that is obtained in that particular operation will be returned in the form of an array. So the same operations can be done with built-in functions as well as with the arithmetic operators also. Suppose I'm having here C is just a variable to which I am going to assign a plus 2. In this case, a is an array to which the value 2 has been added. So when I write like this, it works the same way like np dot add a comma 2. The same the same result is obtained here where 2 is being added to each and every element of a, and that is actually stored in the variable c. So now c will also be an array. So let me write here print c. Okay, now we are done with trigonometric functions. We are done with arithmetic functions. Now let us move on to the other functions like np dot around. So this np dot around, this functions can be applied to a single element also, it can be applied to an array also. So for the sake of convenience, we are just applying to a single element. So np dot around, I'm just going to give here 123.456, and after this I'm going to give another optional argument, say 2. So this is the value, 123.456 is the value that is to be rounded to 2 decimals here. So what will happen is 123.4, and this particular 5 will be added, 1 will be added to it, and it will become 6, because the third digit is actually 5. If it is 5 and or more than 5, that the second digit will be incremented, the same operation as we do in mathematics. So let me run. So 123.46. Suppose I am going to skip this optional argument, that is 2 I am going to skip. So what will be the output? So let me write here np dot around. I'm just going to write 123.456. So when I don't give this optional argument, what really happens is this 123 is converted to an integer. So if this is after the decimal, if I have here 0.4, so what happens is 1 is added here. If it is 0.5 and above, 1 is added to the value and it gets converted. But since it is just 0.4, it will not get added. 1 will not get, it will be just 1 to 3 and not 1 to 4.